probably send a bunch of texts every day, but when you hit send, what happens? How does your message make its way across the room or to the other side of the world to someone else's phone? I'm Greg, and what the physics? To send a message out of your phone, electricity from your battery jiggles electrons in the antenna of your phone, giving off a kind of light. Not visible light like the filament of a light bulb gives off, but longer wavelengths, radio waves, which can be thought of as invisible light. So how does that invisible light encode your message? Well, how would you do it with a flashlight? Maybe you'd shine it on and off with some sort of code like Morse code, dots and dashes, or ones and zeros, binary. When your phone sends the letter U, it turns it into 01010101. Or the message, why don't we text in binary, is this. Then the antenna in your phone sends out the ones and zeros, in short, jiggle stop, jiggle stop, jiggle stop, jiggle stop. Where does the light encoding your message go? Straight to your friend's phone? To a satellite? Nope, the antenna in your phone is too tiny, and it can only send the message a few miles. So to where? You may have never noticed them before, but if you keep your eyes open, you might spot some of these strange fake trees. Have you ever wondered why it's called a cell phone? Well, antenna towers like these are about every few miles, or closer, even in what appears to be the middle of nowhere. Every antenna tower presides over an area of land around it, called a cell. These cells divide our land, and when you send a text from inside a cell, a sphere of invisible light emanates outward from your phone to an antenna tower, jiggling its electrons and transferring the message. But you aren't the only one sending out invisible light. How does the tower know that your message didn't come from somebody else? Like all light, visible and invisible, radio waves come in different frequencies. For visible light, that's different colors. Imagine you have a bunch of people shining flashlight Morse code at you, but you can't tell them apart. If you tell one person only shine in red, and another person only shine in green, then you can distinguish them. That's kind of what happens with phones. The tower tells my phone only text in these particular frequencies, and tells your phone text in these different frequencies. It's like I'm texting in green and you're texting in red. And all across cities and towns, spheres of different frequencies are emanating outward from phones. Now your cell tower knows your message came from you and it needs to send it to your friend. But how does it know where your friend is? Well, you might as well call it a brain cell, because it's connected to all the other cells through a network of computers that knows all. It watches and tracks your friend, you, and everyone you know. Whenever your phone's on, wherever you go, the big computer brain of your cellular network knows. Your friend is in this cell. And to relay the message to them, the big computer brain sends the message through cables to their cell, where now everything happens in reverse. That cell tower sends out a particular frequency to your friend's phone. Those radio waves jiggle their antenna. That becomes zeros and ones, which are translated into the message. And that's what happens when you send a text.